Hey DIYers, what's up? Ferdinand Dandy here of the DR100W Concept Project, a Class D Power Amplifier channel. And in this video, I'm going to talk about my adventure dealing with the TI Texas Instrument one chip Class D Power Amplifier, the three brothers I mentioned in my previous video in my introduction about the NXP migrating to the TI chipset to move from my favorite chipset from NXP, the TDA8920TH, and the other two chipset, the 8950 and the 8954 3250, and we got also the TPA3251 and the TPA3255. Like we got here the TPA3250, I call it the small brother, the TPA3251, the middle brother, and the biggest brother, the TPA3255. So what I'm going to do today is to just talk about the middle brother, the TPA3251, its performance, its electrical characteristics, the things I personally don't like based on a certain reference, how it was built, about the safety, about those what we call RoHS REACH compliance, and so on and so forth. Is that interest you guys? Then watch this video till the end and let's see what kind of learning you can pick up from my small DIY stuff. So what about the TPA3251? Well, on my point of view, as a DIYers and personally speaking, there are challenges actually. They're not really a problem, but it's a challenge that needs to be addressed. So let me go through one by one and let me dive to that. Let's start with the data sheet or the specifications of the TPA3251. Now, if you take a look at the data sheet, you won't find that this amplifier will be loaded with an 8 ohms load, which means to say the load I'm talking about here is the speaker, where it will convert the electrical signal into a sine waves. I don't find in that specification that version that they are specifying that this specific chipset, TPA3251, will load with an 8 ohms load. It looks like to me that they wanted to preserve that kind of high power. That's why that they are only specify the 4 ohms, wherein technically speaking, when you want to load the same amplifier with the 8 ohms, the power will be less. So I think the emphasis here is that TI would like to emphasize that TPA3251 is absolutely getting higher power by using a 4 ohms load. But you know, the reality in these words that people like power because as the name itself, power amplifier. And my limited research shows that there are not so many TPA3251 demo board in the market. I'm talking about here in mainland China, about the e-commerce Taobao. I only few boards, like maybe 2 or 3. But in comparison to the TPA3255, this is the big brother in here with much reserve power. There are several different form factors of this TPA3255, which means to say that probably from a kind of gauge or research that people are actually looking for power and that they are concentrating on the amount of power that a certain chipset can able to deliver. That is the reason why we have lots of TPA3255 derivatives, from a good one, small one, big one, to what else? Copycat, I should say. Now the question is that what is the performance of the TPA3251 when you use an 8 ohms speaker? or when you use a resistive load to perform the electrical performance. I think when I get again another access in YouTube, I'm gonna try to search it, and I'm going to link down in the description below, so you can just go straight to find what is the performance when you load the TPA3251 with a 4 ohms load or 4 ohm speakers in terms of a loud test. I mean live test. Live test. That's so-called sound quality test. All right, guys, that makes sense. Otherwise, I try to find a time to do the performance test electrically, or that so-called parametric test with an 8 ohms load. I'm gonna take away this big brother here and the small brother, and I'm gonna just, there you go, just concentrate on our subject matter today, the TPA3251, the middle brother. Now, let's talk about the electrical performance, or that so-called parametric test. And what I have done, it was sucks. It's because I cannot find the right power supply to deliver that power required to test the maximum power output of the module. I mean, we're talking about again, and again, the maximum power output the module can deliver to the specified load, in this case, specific only to 4 ohms, because it's basically the holy grail of DI wires to know how much power it can deliver to the specified load. And it's because I cannot find 36 volts with much amperage. I just borrow a 36 volts with 6 ampere, which is not enough. So I just constrain on plus 24 volt DC with enough power, and test that one. And my electrical performance test has actually shared already. I put the link down below, and you can take a look at that. To summarize everything that I have done so far, in terms of sine wave 1 kilohertz, I put my electrical performance, and I'm sharing that. Criticize it, take a look at it. You might like to add something in there if my description is not correct. You might find something wrong on the presentation that you would like to improve it for others, future DIYers who might be interested with the TPA3251. You can find it on the description below. This is something that I really don't like so much about the TPA3251 or the Three Brothers. Is about the shutdown, which is when a protection enable, like the temperature protection, then the whole module will shut down. I don't know if that is specific to the chipset from TI, or it's because the way they design it to have a safety matters and the temperature protection. But frankly speaking, I don't like it so much, in reference to the favorite chipset that I had with the NXP solution, or the Philips solution, the TDA 8920, 50, and 54, which is more of a robust, or something like more of a novel one, that it won't die when there is an enablement of protection. So, in a short description, the TI chipset, when protection is enabled, it died. And the only way to revive is to have a cold reboot, or that so-called hard reset, by removing the power supply and then put it back again, and that's the only way you can revive it. But in the NXP chipset, what it does is that, say for example, the OCP, or the overcurrent protection, when the amplifier is suffering from overcurrent due to maximum input signal, which produce a maximum output, it start to enable the OCP, and what it does is that it will going to cut the music for a millisecond, let's say 20 millisecond, depending on the amount of current being consumed. So the higher the current, the longer the cut. So the experience then when listening is that there is a cut, 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 and then of course the users will notice that one, and probably the action of the user is to reduce the volume control, and then the NXP chipset can able to recover that, go back into the normal without this so-called hard reboot or cold reset. So that is the beauty of the NXP chipset as compared to the TI chipset. I mean, repairing again to the three brothers. It looks like my understanding from the datasheet is that it requires an external microcontroller to handle that kind of a kind of mechanism that you going to watch out a certain a port from the chipset, from TI chipset, and you monitor that using a microcontroller, and you do the action. That seems to be the way to go with it in order for you to prevent the uh, the module from completely dying and perform a cold reset or hard reboot. Let's see the artifact comparison of the chipset from NXP and from TI, which is I love the Texas Instrument, the TI TPA3251, because the artifact is very, very minimum as compared to the NXP chipset. This is really evident from this waveform that at 1 kilohertz sine wave, I can produce the big artifacts on the NXP chipset, like these, without those kinds of artifacts in there. But in the TI chipset, they are very minimum. It's not completely eliminated, but it's evident with a minimum impact. And I have demonstrated also in another video, I think in the previous video, that these artifacts will increase the distortion. In terms of distortion, I can see also that the TI chipset is less because of the less artifacts. Think that I can able to show more of these kind of videos, but not in this video. Probably Sheila,
I'm
do you
here,
think
Dandy. What's up?
you can help me to do that?
Easy for me to do that. Will you join me?
Sure, why not? We can schedule a kind of session that we can perform much of the information to show this artifacts difference.
You are the boss. I follow your instruction.
All right, all right. Let's do that in the next video, after this video.
All right, I'm good. I'm always here for you.
I don't have to say that in the real world, these kinds of artifacts, I can able to listen it, or I can determine its effect with my naked ear. I'm not in the position to say that. But the truth is that in terms of Class D power amplifier between these two solutions, the NXP and the Texas Instrumentum, absolutely, the Texas Instrument is much, much, much way better than the previous chipset I'm using from NXP. About the sound quality, pardon me, guys, but I don't have a golden ears to justify and claim that the TI chipset is basically much much better in terms of sonic characteristic or sound quality with the same pair of speaker that I'm using right now. I've been using that with the TDA 8920, the 54, and the 50TH. So I do not change the setup. I'm also using that same kind of music. And I can easily distinguish that the TI chipset is really much better, like more like a good ambient, I should say. Probably that makes them claim that it is Ultra HD, that kind of ultra high definition audio. I'm really not in the position to mention that one, but this is the true experience that I observe, that is observable based on my naked ear. And what else I can say? Yes, apologies for my setup, that it is really, really low cost. I mean, I don't have a good setup. I really don't have that enough money to buy a good audio rack or TV rack. Where can I put it and much more presentable? I'm not in the position to do that right now, but I have the idea, and I have that guts to try to listen to a much better setup than just in my computer or in my table in my computer. And that's the guts I have, even I don't have enough money to do that. And finally, about the form factors of this module, I think that that's quite good to me. I have reviewed that in what I call it the teardown test in one of the videos previously I posted, that basically it goes into a kind of design process. And I believe that this was reviewed in terms that it can work as a kind of demo board, but not real for real product that can last long in terms of reliability, because there is a concern actually about the proximity of the heatsink and those big capacitors in there. They are quite close, and that impose a kind of risk and reliability, because my test shows that the temperature surface goes up to like 73, 75 degrees centigrade. That is an open one, not yet inside the box or enclosure. And with that kind of a proximity of the heatsink and the big capacitors, and that is imposed a reliability risk. But anyway, this is not a kind of intensive product that will going to use for a long time. This is actually a kind of toy to me for bloggers like me to get the trap to buy it and then review it and publish it. It's not something that used for long term, like those real audio amplifier design that go through a rigid testing, rigid design qualification, testing those kinds of high low temperatures, ESD in a short kind of test, like shake, bake, rattle, and roll test. This board, it won't go to that kind of test. It won't. Trust me, guys. Trust me. And also, I'd like to mention also about the chemicals, which is many bloggers fail to mention about this one. There is actually a regulation on the chemicals that being used in the manufacturing, in electronics, in assembly, that impose the health of human users like me, like you, and like others. I mean, earthlings. I'm not talking about the aliens right now. I don't have any idea what kind of sensitivity they have. But for earthlings who's not subscribing to my channel, I mean, that's there is a regulation on the rows that is under restriction on hazardous substances, and I have no way to figure it out whether the kind of solder paste or soldering that they have been used in the product is lead free. If you heard about that one, no demonstration. The kind of chemical that they use to clean that, I don't know whether it is hazardous to the health or it is absolutely hazardous to the health. No demonstration that I can find right now. The only thing that I can do is to protect myself. Means when I'm dealing with it, I don't have to touch my eyes, my ears, my mouth, and so on and so forth, or going to eat. I have to wash my hands, and then I start to do this stuff. Touch your eyes, touch your ears, so on and so forth. Those are the safety matters that I can share about dealing with the TPA3251 or any board that is naked, not yet into its enclosure. Guys, wait a minute. I'm bringing in the standard case that I'm using, which is like to show you that the lower one I'm going to use this case for the TPA3251. I haven't done that. Just for these two, this is the DR700W or 700 watt. There is a 350 watt per channel based on the IRS 2092. That's called the discrete Class D. I would say it's a discrete Class D because it's not like the TPA3251 that is like a one chip solution. And the other one here is what we call the worst amplifier so far, the one chip Class AB power amplifier. That is the worst amplifier I ever had, with lots of crossover distortion, and it's driven by the SAM-UC. It's a microcontroller based that it needs to protect the speaker from a dangerous power amplifier like the one chip. So this is the next project that I am going to do with the TPA3251, which is going to be somewhere in the next coming months, depending on my schedule. So that will gonna be again another adventure that in terms of temperature, that how much this heat sink or this module can able to handle when I put inside its enclosure with a minimum ventilation, that it can able to handle without enabling the protection circuits like the thermal protection circuits. And of course, there will be again another kind of adventure when I start to put my HMI, the human machine interface LCD, runs by a next gen LCD. I mean, runs by with a next gen LCD. This is a 2.4 LCD in here, and then runs by either maybe Arduino solution, ESP32, or my favorite Intel 8051 or STM32. I don't know yet. I always mention about CALAS, means collaborate, avail, learn, access, share, and support. I always mention about this one because I'd like to collaborate. Actually, one of my success is to cooperate with my friends or anyone out there. The DR 100 watt concept project was made and successfully done because of collaboration, and I hope that I can collaborate as well with the TI chipset or any other else. I mean, much better for collaboration or cooperation in going to hike, camping, drinking is there, no worries, and also go to anywhere interesting.